So we want to take a moment and just take note of some special triangles, the isosceles, the equilateral triangle, and the right triangles. And just take note of some special properties that they have. First of all, the isosceles triangle. Remember, an isosceles triangle has two sides that are the same length. Okay, so we call those sides the legs. So in this example over here with this isosceles triangle, we have the base, and then we have the two sides that are the same length, and then we have the vertex up here. Okay, the vertex angle right here. Okay, opposite the base. Okay, so that's just some terminology that, some language. Now, one of the things we can note about these isosceles triangles is the angles opposite those congruent sides are themselves congruent. So this is called the base angles theorem. Okay, so these angles are congruent. So in this case up here, you have these two sides being the same length. The angles opposite are congruent. Now the converse of that is also true. If the angles are congruent, if angle B is congruent, then this side over here, see? If this angle right here is congruent to this angle, then the two sides are congruent. So it goes both ways. The two congruent sides, the sides opposite, those angles are congruent. Two angles, the sides opposite those are congruent. So it works both ways. Now, what I want to do is I want to just play around with this a little bit. It says use the diagram of ABC. Okay, so here's this angle ABC to prove the base angle theorem. In other words, what I want to do is I want to prove that this angle right here is congruent to this angle right here. Okay, so let's just start off with a proof. So I've got a statement, and I've got a reason over here. Okay, now, so first of all, we're given that triangle ABC. So we're given this triangle ABC, and we have that AB is congruent to AC. Okay, so that's just given to us. Okay, so we know those two sides are the same. Now so this is given. Now we also know this. We know that AD is congruent to itself, right? Obviously, and that's reflexive. Reflexive. Whoops, I almost spelled it reflective. Reflexive. Okay, there we go. There we go, reflective property. Okay, so now, let me just put that here. Now let's see what we have. We have that the triangle ABD, let's look at this. The triangle ABD is congruent to the triangle ACD. Now, how do we know that? Well, we've got side, angle, side. Okay, by side, angle, side. There, that's the proof right there. Okay. So that's the way we could show the base angle theorem. Okay. Now, we could apply this to the equilateral triangles as well, because we've got, obviously, an equilateral triangle, we've got these pairs of sides the same, so this angles opposite are going to be congruent. And you could look at any pair of these sides and the angles opposite are going to be congruent. So if all three sides are congruent, then obviously all three angles are congruent. So equilateral triangles are also equal angular, and angular triangles are also equilateral. Okay, so Now, let's go down here and look at an application here. We've got a situation where we've got a triangle, and we want to find, now these weren't given to us. This is just all that was given to us. So we want to find x and y. Now, we were just told that the sides, the angles opposite the congruent sides are also congruent. So this is x degree, and this is x degree here. That's an equilateral triangle. Now also on this other triangle, this, the side opposite these congruent sides, you get, if this is y, then this is y also. Okay, so let's see what we have. As far as the x's go, if you do 3 times x, if you add these x's together, that's got to add up to 180. So x must equal 60. Okay, so x equals 60. Now we got to figure out what y is. Well, remember that we observed before that x is going to equal the sum. Notice this x is an exterior angle. So it's equal to the sum of the opposite angles. See? Not these two angles over here. So it's y naught, or y degrees plus y degrees. So here's what we've got. We've got x equals 2y. Okay? Because this is an exterior angle, and an exterior angle, remember, if you've got alpha and beta, and this is gamma, alpha equals alpha, or gamma equals alpha plus beta. Okay? It equals the sum of these two angles over here. So that means that, looking back up here, I've got 2y equals 60. I just replaced the x with 2y, and y equals 30. So x equals 60 and y equals 30. Yeah, there we go. Okay, now let's go over to right triangles. Now remember, we've got methods for proving that triangles are congruent. We've got side, side, side. We've got side, angle, side. We've got angle, side, angle. And we've got angle, angle, side. Remember those ones. Now, we're going to add to this hypotenuse leg in the case where we're working with a right triangle. So we're going to use that now. If you have the hypotenuse and the leg, two triangles, and the corresponding hypotenuse are congruent and the leg is congruent, then you've got a congruent triangle. Okay? So that is just something else that we add on to, one more thing that we can use. Now, for the assignment, you'll notice this is mainly computational stuff that I've got you on this assignment. Okay, the last assignment we did some proofs. This assignment, I think I'm just going to do more computational stuff. Okay, where we use, those theorems.